Hello there. Today we'll be doing rotten oranges. So this is our number 84. In rotten oranges, we are given a bunch of oranges, and can have multiple oranges that are rotten at the same time, and they could spread from both different directions. So this is going to be BFS problem, and every time we get through the borders that we got, let's say this one and this one, time will increment by 1. So we're gonna have to start with a Q and some constants. So rows, columns equals length of grid, and this is the length of grid 0. Then we're going to create a queue, which is equal to dq, so that we can pop left time, and we have to keep track of the time and number of fresh oranges. 0 and 0. Okay, so with that, let's add all the rotten oranges to our queue. So for I in, let's just for RC in range rows, and for C in range columns, let's append these rotten oranges into our queue. So now we have some rotten oranges, right? Wait, they're not rotten yet. So if grid of R and C is equal to let's say 1, then that means that there are fresh oranges, and fresh oranges plus equals 1. Else if grid is equal to 2, then we're going to append these rotten oranges into the queue. So we'll append R and C, this particular coordinate. So from this coordinate, we're gonna have to check the 4 different directions from this coordinate, and if they are going to be 1s, let's put them into the queue. So because they became rotten, and if they do not become rotten, then let's not add them to the queue. So this is a little different from them checking our previous problems where we go to the item first, but this time we check the item first before we go, because we need this information about our current orange. So anyways, so while Q and fresh is greater than 0, let's go do the range of items that are in our queue currently, because we're going to keep adding items to the queue without creating a separate list, and that's a whole mess. So this is an easy way to do it, so let's do it this way. So we're going to pop left, and we're going to create directions in 4 different directions. So R plus 1 of C, and R, so let's make this easy to read. So R minus 1 to C, so that we don't make mistakes. And this is going to be R and C plus 1, and R C minus 1. Perfect. With that, that's how we get our 4 different directions. Ooh, that is not clean. Let me think about this like this. Let's say directions equals better or worse. I think this is one way to do it. It looks cleaner to me. I'm not sure like about you, but this is how you can set up the 4 different directions. Make sure you get through them. So for direction in directions, we're going to make sure I'm going to set RC to directions direction, and what's going to happen now is that if grid of R and C is if it does not equal 1, like we can skip it, but we'll also need to do some checks as usual. If it's less than 0, or RC is less than 0, or R is greater than or equal to rows, or C is greater than or equal to columns, or it's does not equal to 0 to 1. If it is 1, that means we can start spreading this rotten orange. So this particular RC is going to be grid at R and C is going to be equal to 2 now. And what's going to happen is that we're going to Q dot append this particular direction. So so that we can branch out from this direction. After this, we exhaust everything from the queue. Of course, we have to minus a fresh orange. Minus equals 1. Of course, once we've exhausted our queue, that means we have completed one cycle. That means one time period has passed, so time plus equals 1. And with that, we can return time. But that's if the fresh oranges are exhausted. Equals 0. Otherwise, just return -1 because we have not exhausted all the what do you call these things? Oranges. So the bad thing about writing two-worded value variables is that you might forget the type word of it without auto-completion. So okay, we have solved it. Not too shabby. And yeah, so this is a problem where we had to, I guess, look into the direction before we go into it, rather than our previous problems, like let's say surrounding regions, where we could use this type of code where we didn't care about our previous items, and we just wanted to set every single item and throw everything into a queue. Or this particular question here, we just did, where we threw everything into the queue. It didn't matter as long as we went into every single direction. So it was a little different. Anyways, I'm really glad to have done this problem. You to know that sometimes we have to view in the future before we can add things into our queue. And make sure that we are adding the right items to the queue and starting from the right point of the queue. So to each problem, you have to have it's cleaner in a different way. So that's the lesson here. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below, and I will see you in the next one.